So there, hello, machine is number 20. And there's number 22. Excuse me. Number 24 is that one. Yep. Number 26 is coming right up. There he is. He's a little blurry, but there he is. Number 28, a little less blurry, and there he is. Number 30, did we do 30?
Apparently, yes.
Why did I assign 30? Did I assign 30?
Pretty sure.
30a is 1 over x equals 1 over 30 plus 1 over 45 all over 2. And then 30b is 36. But 30 is really more some of the types of things that we're going to do today. So, whatever. Your mileage may vary. Do you have any questions?
26.
26. How many are there? No, that's 36.
Yeah.
So, just throwing this out there on the video so that they will hear what I have to say. Today, only 1/3 of my class is currently here. For those of you who are my students, you need to know that this class, because of its size and its level, will happen no matter who is here. I already said this before I started the video, but even if nobody shows up, I will show the answers, I will teach the lesson, and then I will turn off the camera. So, there you go. Let's talk about solving rational equations. I suspect strongly that we will end up getting through the rest of this lesson and the next lesson and starting the next lesson.
Were we doing 26?
Oh yeah, you did ask a question. Yeah, sure, we can do 26. Why not? 26. Oh look, 26 is kind of fun, so that'll be good.
Yeah.
Let's do it. 26 is f of x equals x squared minus 4x minus 21 over x cubed plus 2x squared minus 5x minus 6. And we are told to determine the asymptotes, holes, and intercepts, then graph it and state its domain. So, how should we do that?
Factor out the denominator.
Back to the denominator and the numerator for that matter. Yeah, so let's factor out the numerator. Start there. That one's easy. Assuming it's factorable. X, and then 7 and 3, right? Yeah. 7 and 3 minus and plus. This one is slightly less easy. What should we do?
Find all the possible real zeros, which is 6 over 1.
Yeah, so it could be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. True enough? Which one is it?
It's -3.
Great. -3 See if it works. See if you're right. 1, 2, -5, -6. We're in the 1, -3, -1, +3, -2, 6. You were right.
Yeah.
Now what?
Now we just factor out the x squared minus x
Yeah.
minus
So we've got x plus 3 times x squared minus x minus 2. If we're lucky, this will just factor. 2, 1, minus, plus. It does. Happy days are here again. So now we have the factored version. F of x equals x minus 7 times x plus 3 over x plus 3 times x minus 2 times x plus 1. Now what?
Cancel out the x.
Yeah. But we got to notate real quick, right? That there's a hole at x equals -3. Right? So that's important that we notate that before we poof it away, or else we're liable to forget. So then we're just going to graph x minus 7 over x minus 2 times x plus 1. I'm going to go ahead and erase the synthetic division bit so I have more space. I can find something to erase it with. Now we're going to graph that thing. So we need to know about whether or not there are asymptotes or all of those things. So let's start with the obvious one. Yes, there are vertical asymptotes. Where are they?
2 and x equals 2 and x equals.
Yes. It has vertical asymptotes at x equals 2 and x equals -1. Sorry, I was trying to see if I heard anything from Landon or whatever, but I don't think I did. Okay, great.
And a horizontal asymptote at y.
Yep, how do you know that?
Because the degree of the numerator is less than the degree of the denominator.
Are you sure you got it right this time? You kept getting that backwards last time.
Yeah, I did get it last time.
So you've got it down now.
Yeah, today is a new day.
Today is a new day. Great. Start doing some graphing.
Yeah.
Okay, so at 1, 2, and at -1, we've got asymptotes. Let's go ahead and find the rest of that hole next. So when we plug a -3 into this guy, we've got -10 over -5 times -2. So at -1, does that sound right? -1, -3?
Yeah. And we'll file just 2 over 2, which is
There's 3 negatives. It's going to come out negative. You made me second guess what I was writing. All right. At -3, -1, 2, 3, -1, there is a hole. Great. Okay, now what?
Get some points ready.
Grab some points. Sounds good. X, f of x. So let's do like negative 10, negative 4, negative 2, 0, 1, 3, and 15. That'd be enough to get our trends. And since we're in pre-cal, not algebra 2, you can shove that in and look at the table. So what do you get out of your device?
So for negative 10, we got 0.16.
That's good enough. 0.2 doesn't make 0.1, 0.2 on our scale are the same number.
Yeah. Negative 4 is 0.6. 0 is.
You skip negative 2.
Negative 2 is negative 2.25.
Negative 2 point what?
25. Negative 2.25. 0 is 3.5. 1 is 3. 3 is negative 1. Yes. Positive 3 is negative 1. 15 is 0.04. Really small.
There's one more point that would be useful, right?
Right.
That would be the y-intercept. Where is the y-intercept going to be?
It's going to be nowhere because it's. Well, I mean, like.
The y-intercept, not the x-intercept.
The y.
The y-intercept.
Where intercept.
How can we find that?
X equals 0.
We've set the y equal to 0 and then solve for,
Right.
right? The y-intercept, not the x-intercept. No, just kidding. The x-intercept. I don't know what I'm saying.
Okay.
Yeah, both would be useful. We already found one of them. We already found the x-intercept right there.
Yeah.
Great.
That's why I was confused. Yeah, so it's.
The y, I don't know why I'm saying things backwards like this entire time. But the x-intercept
This would be 7.
at 7.
Which is.
Great. Okay, so let's put some dots on the board. We're approaching 0 over here, right?
Yeah.
There's I didn't dot in our horizontal asymptote. There is one, right?
Along the 0 line.
There is one of those, and so we could have expected that it was approaching 0, right? Just from what direction? It's approaching it from down, right? Because it's coming from negative 2.3. So our graph is going to be, it's got a hole here, and it's approaching 0, so it's going to go up this way. And then it's going to go down this way, which was another clue that it was going to be down there because of our hole there, right? And then we've got 0 and 3.5. 1, 2, 3.5 is right there. And we've got 1 and 3 right here. We may need a little more information in our little middle chunk.
Right.
I have a suspicion of what's happening, but
Probably going to do like a inverse.
but we need a few more things. Let's grab a few more things. Negative 0.5 sounds great, and then let's do 1.5.
Which is.
We may even need a little bit more than that, but
So negative 0.5 is 6, and 1.5 is 4.4.
4.4. So negative 0.5 is 6. 1, 2, 3, 4, 5, 6. Right here. And then at, oh, that goes with this. I don't know what I'm doing. 1.5 and then 4.4, yeah. Okay, so that's what we probably expected because there's not a x-intercept in there, at least not one that we discovered through our tests. So it's going to kind of go like whoopie-doop, right? It's got kind of a little, we could get a few more points and get, there's going to be a little curvy thing bit there, something strange. So we could detail that out, but for our purposes, that's plenty accurate enough, right? So then we've got 1, 3, oh no, I already did that. Did I not do this one? Oh, I did, there it is. 3, -1. And then 7, 0. 1, 2, 3, 4, 5, 6, 7, 0. 15 is really small. So what is this chunk going to look like? And it's going to approach 0 with its end behavior, I suspect. You can put in, when we put in like 100, what is 100? What? Is your thing broken? We should probably, what are you doing? You're going to make me pull out my graphing calculator?
Wow, it's 93 over 9,898.
Yeah, so really small.
Really?
Yeah. So it is, so it's going to, probably to get enough detail, we probably want to do like 8 and 6 to see how much of a bump is here. But there's going to be a little bump there, right? All right, but and then it's going to come back and it's approaching 0 going that way, right? Easy peasy. Make sense?
It's positive. Hold on. It's above 0.
Yeah, I know. I used on 8. That's what I said.
Okay.
That's what. Okay. Let me slow down a chunk. What is it at 8?
At 8, it is like just above 0.
Yeah. So 0 point tiny.
Yeah.
Go ahead. Let's go ahead and get a few more. Let's grab like 10 to get closer in there. Oh, 15, yeah, 15 goes. Yeah, this is above 0. 100 is above 0.
Yeah.
It's at what was your? I don't understand the.
I thought the asymptote was at 0, so shouldn't it like not pass it at all?
Oh, you'd think, but no. That's some in behavior shenanigans. It's going to come from here. It passes here, and then it has a little bump, and then it's going to continue on down its path. All right. All right. You have any other questions? No. All right. Solving rational equations. Easy peasy. If you say so. Okay.
Is it 2-6 or?
No, we're still in 2.5. We're doing the last little chunk, and we're gonna. This is review. We're gonna do like 2 examples, 3 examples. Just kidding, and then we'll head to 2.6. Yeah, we should have enough time to do both of those things. All right, so this is just solving rational equations. We will start with this one. We'll start with solve for x, and the equation is 9x over x minus 2 equals 6. All right, so when we're solving a rational equation is an equation with letters in the denominator. Our first step is always to get rid of the fractions. It's always our first step. And just like if they were numbers, we do it the exact same way. We multiply by the least common denominator. So what is the least common denominator in this chunk? x minus 2. So we multiply x minus 2 on this one, they cancel, right? So you're just multiplying times 1 on this one. So 1 times 9x is still 9x. And this one, nothing cancels. So 6 times x minus 2. So 6 times x is 6x minus 12. It is not a bad idea to not do that in your head, especially when we get a bunch more things, and to write 6 times x minus 2 and then do that as another step. That's not a bad idea at all. And then it's easy peasy, right? We just subtract 6x, and we get 3x equals negative 12. And then we divide by 3, and we get x equals negative 4. Bob's your uncle. Easy money. Problem solved. Great. Let's do another one. Another 2, in fact, actually. Because I want to pick up that one. Because it's important that we include it, since this is the only lesson you're going to get on it. Unless you go back and watch the Algebra 2 videos, which you could do. What happened? Did you move the cursor on accident?
Is it like a touch screen or something?
It is a touch screen.
I just like flipped the computer
That's
down
funny.
and put it back up and then.
That's funny. That's funny. Well, at least you didn't stop the thing. Worked out well. I don't know what I'm doing. Okay. Let's do 2x over x plus 3 plus 3 over x minus 6, equals 27 over x squared minus 3x minus 18. So what are we going to have to do first before we find least common denominator? Factor, I agree. You know what else dawns on me is because of this mic and the way I'm doing it, the camera can't hardly hear you. So even if y'all weren't here, I could pretend like you were talking to me and be like, yes, you factor. That would be funny. Okay, anyway, somebody walking by might think I was schizophrenic, but you know, whatever, it's fine. Factor x and 6 and 3 and minus and plus. Looks great. Surprise, surprise, since it is a textbook problem, it even kind of matches.
Wow.
So what is the least common denominator in this particular problem? X minus 6 times x plus 3. That's right. All right. So now we distribute. When we distribute on this one, the x plus 3's cancel out. So we're just going to do 2x times x minus 6. So 2x times x is 2x squared. 2x times negative 6 is negative 12x. Watch this sign in the middle, because if it's negative in the middle here, you're going to have to distribute a negative. So, that bit easy accidental mistake to make. So then same idea here. The x minus 6 is canceled, so we're just doing 3 times x plus 3. So it's plus 3 times x, which is 3x, plus 3 times 3, which is 9. The last one, everything cancels. So all we've got is just 27. Then we solve it. How are we going to do that?
Combine like terms and subtract 27.
We should subtract 27, combine like terms. I agree. Like terms right there, and subtracting the 27. We're getting the 27 off of that side and onto this side, so we can hopefully, if we're really lucky, factor. I closed the wrong one. 2x squared minus 9x minus 18. Does that sound right?
That's what I came up with in my head.
Yeah, either both our heads are wrong or they're both right. All right, now we're going to factor. I was hoping that the 2 was going to divide off, but it doesn't. That's all right. At least there's only one option for 2, right?
Yeah.
So we got 2x and x. And then let's see, we could do 9 and 2, definitely not going to work. 6 and 3, I bet, is again what's going to happen. Let's see. 6, and then 3 would be 6. Over there would be 12, and then 3. Nope, that still doesn't
12
work.
minus 3 is, well.
No. 9 and 2 maybe does work. No, it can't work.
No, yeah, it's 6 and 3. 2 times 6. And then
6, 3,
12.
3, and oh yeah, that does work. Yep, you're right. You are completely correct. So minus and plus. Oh, this problem also has the same lovely thing. So if we solve each one of these factors for 0, set them equal to 0 and solve them, we end up with x equals negative 3 over 2 and 6. But there's a problem. There's a flag on the play. What's the flag on the play? We didn't make a mistake this time. But there is a problem. We can't have a 6 in the denominator. So this is not the answer, but this is. Aha. Let's do one more. And then we'll move on to the next lesson. We're making great time. I thought we would. I figured that this chunk would go by very quickly. I didn't figure wrong. It's almost like I've taught this before. I suspect by the end of today, I will be able to answer your question from earlier.
What was my question from earlier?
When is the test? Yeah. What am I writing? 6 plus x minus 2 over x. I was looking at the test earlier today. It's a good looking test. What should we do now?
Finish writing out the...
Yes, you should finish writing out the equation. Sounds good.
Okay. Factor.
We should. We should factor. I agree. How do we do that?
Just take the x out of it.
That's true. Just a GCF it. X out, and then we're left with x plus 6. Astonishingly, they match, right? Big bracket. Our common denominators, x times x plus 6. Here we go. The first one, it all disappears, right? Just left with 12.
Equals.
And then that one, x plus 6. So just 2 times the x, 2x. That one, oh no. We've got x's canceled. We've got x minus 2 times x plus 6. So you can use the FOIL shortcut and do it in one, or you can do it in a couple of steps. If you distribute that all out, x times x is x squared. I'll go ahead and write it all the way out this time. I like to use a shortcut in pre-cal, but let's write it all the way out. Or I'm going to. You can do whatever you want. X times 6 is 6x. And then negative 2 times x is negative 2x. Negative 2 times 6 is negative 12. Combine like terms. Oh, look at me. It's also the same number of steps. Either way. Combine like terms. And we can subtract 12, because why not? Minus 12, minus 12. And we've got x squared plus 6x minus 24 equals 0. Okay? Then we hope to factor it. X and X. 12 and 2, 24 and 1. 8 and 4. 6 and 2. 6 and 8 and 6. Yeah, what is it? 6 and 4. No, not 8. What are you saying? 1 and 24. You got me saying weird stuff now. I'm going to write them out. And 3 and 8 and 4 and 6. Yeah. Which of those make 6?
Let's see.
If any of them.
8 and 3? No, that's 5. Well, crap.
Well, crap indeed.
Okay.
Okay, so what do we resort to now?
Complete the square.
Complete the square, sure. I thought you were going to say quadratic formula, but that's fine. X squared plus 6x equals 24. We do the green part. B divided by 2 squared is 3. Squared is 9. Plus 9 plus 9. This is not, I feel like either we made a mistake or the key did. Because I don't feel like this is going to end up with the answer that it says it does. But we'll find out in a second. X plus 3 squared equals 33. Square root both sides and end up with x plus 3 equals plus or minus the square root of 33. Subtract 3 from both sides and end up with x equals negative 3 plus or minus the square root of 33. Which doesn't give us no solution. Doesn't give us, does it? Does it give us no solution if we plug it into this one? No. Negative 3. Well, I don't know. That squared might equal. It might. I don't think it does, though. We'd have to double check it, but I don't think that gives us no solution. Punch that in your calculator.
Which one?
Dude, because it's not gonna make this not work, and it's not gonna make this not work. So if it's gonna do anything, it's gonna make that not work. So you'd punch negative 3 plus the square root of 33 squared plus 6x. 6 times that. Negative 3. There's no way.
That one equals
There's like.
Plus equals 24.
This equals 24?
Plus, yes. Plus equals 24.
There's like no way. If it does, then that's going to be mind equals blown.
They both equal 24.
Both equal positive 24, or this one equals negative 24?
No, I put it in right. They both equal 24.
Both equal positive 24?
Hold on. Maybe it's a weird negative.
It could because of that's, it's not impossible. I'll punch it in too and see if I agree with you. Let me see. Because that's going to be wild if that ends up equaling 0 on both of them, no less. That is going to be crazy. Negative 3 plus square root 33, close parentheses, close more parentheses, squared plus 6 parentheses, negative 3 plus square root 33. That one definitely equals 24. I agree with you. see if this one equals positive 24 as well. Did you already double check them both?
I'm double checking by putting like -3 plus 33 in and then doing that.
Gotcha.
So there's no negative shenanigans.
Yeah, no, that one doesn't equal 24. That one equals 16 point some irrational thing, which makes sense. Yeah, of course it does. Of course it equals some irrational thing. There's no way to turn that with just multiplying times 6 into something not irrational. Yeah, definitely. So this is the answer. I don't know what the book is smoking. They went crazy. Unless we made a mistake. Let's double check that really quick. This one, everything cancels. This is, we copy things down right. Yes, great. Okay, this one, everything cancels. It's 12. This one, all we have left to multiply is 2 times x, so 2x. This one, x squared, so it should be, that's these two. So it should be x squared plus 4x. There it is. Dang it. Oh no, just kidding. I did make a mistake going to here, right? Oh no, that would cancel with that. No, I didn't make a mistake. So these together would be 4x. That's what I just did in my brain. 4x plus 2x is 6x. That's not a mistake.
Yeah.
And we subtracted the 12. Got negative 24. Made no mistakes. That's the answer. The key is broken. Great. I should write that down in the key so that I don't not know that in the future. And then assign a little bit of homework on this one. And then do the next one.
So it is irrational, but it's still 20. It rounds to almost exactly 24. It's like
on the positive one?
The both. Like
when I did it, I got 16.47.
And then you add that to that, you get somehow almost 24.
Add that to this?
Yeah.
No. Because that gives you 24.
What? -3 plus.
This one gives you 24. This one gives you this.
So -8.7.
This one gives you that. So that plus 24 is definitely not 24. It's a little more than 40. It was -3 plus or minus. Plus or minus the square root of 33. Great. All right, so your first set of homework is going to be numbers 32 through 42 evens on page. There it is. Page 138. Numbers. What did I say? 32 through 42. Yes. 32 through 42 evens. And then let's do 3, 6. Excuse me, 2, 6. We're not in chapter 3 yet. Why are you lying to me? Okay. Nonlinear inequalities. Sound fun? Yes. Let's do it. We really only need like 2 examples. That's what I thought. Yep. That's easy money. Which means the test is going to be on Thursday.
Next Thursday.
Today is Thursday.
Today is Thursday.
So technically, yes, this Thursday, but not when you're thinking. So let's put that on the board before we forget that too. Because we will do this lesson, assign homework on it. We'll go over the homework on Tuesday. Then you will take the test on Thursday. Test 2 is going to be on whatever day that is.
7 days from now.
Thursday, 10/16. Which, yes, is in fact 7 days from now. That's true. Okay. Now, nonlinear inequalities. We're gonna start by just doing an example.
Yay.
We're going to solve x squared, excuse me, plus 5x plus 6 is less than 20. Your answer on solving an inequality will always be a range of numbers. It'll be from here to here. It's true. Okay, so that's what we're ultimately looking for. So we can start by solving it like it's an equation. You're going to basically turn that into an equals and keep going, right? So if that was an equals, what would we do?
Subtract 20.
Subtract 20. Easy peasy. So we'd end up with x squared plus 5x minus 14 equals 0.
Fine, whatever. Okay.
Who cares indeed?
Factor.
Factor it if we're lucky,
7 and
which
2.
we are. Yeah, it does work.
Positive 7 and 8.
2 minus plus. So the way that I teach this, and the book does too, good, it's great. I feel like there's another way to teach this, but I feel like this is always the way I've seen it. So I don't know, maybe there isn't another way to teach this. So we essentially, so this is going to be a parabola, right? That's if we were to like graph this shape with an equals there, it's going to be a parabola. So we need to know whether it is so like let's say the parabola was this. So it's typically going to be either between these bits or the outside bits. So it's either going to be true here, it's going to be true in this chunk or in these chunks typically. Okay? So those are kind of our options. And so what you have to do in order to figure out where it works is you kind of almost flatten it down to 2 dimensions. We have 2 critical points. We have a critical point at -7, and we have a critical point at 2. We need to do a test in each one of these chunks to see whether it works. And just like when we've done this before when we were solving inequality equations without squares and when we were solving linear inequalities in Algebra 1 and whatever, if it works for one point in that chunk, it works for all the points in that chunk. Okay? So we pick a number over here. What number do we want to pick over here?
-10.
Sure, -10. And then you can plug it in the factored one or the not factored one. Doesn't matter. I think generally it's easier to do it in the factored one. So we plug a -10 in here. We've got -3 times -12. And we want to know, is that less than 0? So positive is what we're going to get, so no, right?
Yes.
It doesn't even matter. Sometimes that can, because we're dealing with greater than, less than, sometimes that can be an easy thing to look at. We don't even have to do all the things. So that section doesn't work. What about this section?
0.
0.
7, -2.
Yeah.
-14.
So that works. Yeah, it's negative. Since people can't hear you, and you're the only one in my class here today, I should say those words out loud so they can hear. So what you just did is correct, and this is even the way it does it in the book is it kind of breaks it simply down into positive times a positive Works, negative times a negative, whatever else, like is the answer positive or negative? So when you plug in a 0 in here, you end up with a positive 7 times a negative 2, which is negative, so it works. If we plug in something bigger over there, positive 10, sure, why not? 17 positive times positive 8, positive, doesn't work. So our answer is, it is between negative 7 and 2, not inclusive. Right? It's between those chunks. Let's do another one.
Right. And if it was like outside, you would use the brackets and not parentheses.
If it was equals, that you would use brackets. If there's a line underneath. If it looked like this, then it would be. Yeah.
Yes.
Yeah.
Because that's not like an X, Y.
Right. Got to think about the context. This is interval notation, not an ordered pair.
Right.
Yeah. Yep. Let's do another one. We got lots of time, right? Well, we've got a little bit of time. We got a little bit of time. So that's all right. This one won't take very long anyway. So let's do this one. We got 2 examples in us.
Oh yeah.
If we don't, I'll stay late and finish it and record it, and then you'll have it. That'll be fine. Greater than x minus 4 quantity squared greater than 4. Right? So, what should we do? Square root both sides sounds like a great idea. I agree. Take the square root of both sides. So we end up with x minus 4 is greater than plus or minus 2. Then we add 4, right? Easy money. X is greater than 6, and x is greater than 2. We don't know the greater than bits, right? Those are just our critical points, right?
Oh yeah, because it's plus 4. I'm sorry. I was subtracting 4 from negative.
Yeah, you made a mistake instead of me. That's good. That's always a good day when you're on the whiteboard and you don't make the mistake. So we got some critical points. Got to think about where they're going to work. All right, so we've got 2 and we've got 6. Pick one over here, pick 0, because we always pick 0 and pick 0.
Negative 3.
Is
or sorry, 0.
actually, if we picked, no, just kidding. Never mind, just kidding. If we pick 4 in here, that's going to be a nice one. But we picked 3, what am I saying? 0 over here, we got negative 4 squared is greater than 4. Yes, because 16 is greater than 4, right?
Yeah, yes.
Yes, he works over here. If we pick a 4 in here, that's going to be great. 0 squared is not greater than 4. He doesn't work over here.
Whoa.
Pick something over here. How about 8, 7, whatever, I don't care. 7, sure, it's fine. Or we couldn't pick 5. 7 minus 4 is 2 squared. 7 minus 4 is 3 squared,
Yeah.
which is 9, which is greater than 4. Great. So he works. So, how do we write that?
That's a good question.
In fact, let's do this and do one more additional.
Negative infinity to 2.
Negative infinity to 2, not including the negative infinity, but including the 2, because I added that onto our initial.
Added it on
I
there?
added it just now, because I want to make sure that's in our notes somewhere, right? Yeah. Unioned with 6 to positive infinity. And you can, if you want to write these in set builder notation instead, that's totally fine. Either one is fine as long as you do it correctly.
Yes.
As long as our answer is a member of the real numbers. Because if it's not, you can't do interval notation. All right, let's do another one. We do have time. I'm going to do all the examples regardless because we're going to finish this either way, even if you have to get up and walk out.
Oh, my grandparents going to be a little late anyway.
See, it works out in everybody's favor. Let's solve this one that looks scary. Let's solve this one that looks a bit scary.
You know what Landon was saying? He would say, oh no, it's not going to be scary.
Well, maybe. Let's do all three of these. I'm going to do all three of them.
Same time?
No, not at the same time. Solve x plus 6 over 4x minus 3 greater than or equal to 1. So we need to find our critical points. There's more of them than it looks like. Right? There's more there than it looks like. So what do we do first? What did we do last lesson when we were attacked by something like this? Yeah, that's true. We're going to clear the fractions. Don't erase them from your page because we're going to need that denominator again in a minute. Like, I don't know why I would erase it from the page. I don't know either, but sometimes students do weird things. So our common denominator is 4x minus 3, right? Yeah. Multiply it over here, everything cancels, right? We're basically solving a proportion on this particular one, right? Yeah. Plus 6. I'm just going to change this to an equals because we don't really care or know anything about that yet until the end, right? And then nothing cancels, so all of it's over there. So 4x minus 3. Easy money. Then we're going to solve. We subtract 4x from both sides and end up with negative 3x, and then we subtract 6 from both sides and end up with negative 9. Have I made any mistakes yet? I don't see any.
Hold on.
Oh.
No. Yeah, we're good.
Are you playing along at home? 3/4 and 3, between 3/4 and 3. Oh, yeah. Good job. Even with the delay, you finished because you already knew how to do it, and I'm teaching it. Anyway, divide by negative 3 equals x equals positive 3. So we have one critical point. No, we don't. We don't have one critical point. We have two critical points. Because we have the one that would be when we set this equal to 0. So our critical points are 3 and 3/4. So we've got to test those regions.
Yep.
Right? So we're going to test 3/4 between, you know what I'm trying to say. Words are not wording in this class today for some reason. Shove a 0 in there. Sounds great. If we shove a 0 up here, we end up with negative 2 greater than 1. No, doesn't work. Sad face. What can we put in here? Sounds good.
Huh?
I said, what can we put in here? And then I guess you were doing something.
1.
1 sounds great.
1 plus 6.
1 plus 6 is 7. Over 4 minus 3, which is 1. So 7. Is 7 greater than 1? Yes.
That does work.
Check something out over here. So how about 4, right? So 4 plus 6 is 10. 4 times 4 is 16, minus 3 is 13. So is 10 13ths greater than or equal to 1? No. So it is inclusive 3/4 to 3. Easy money.
Wow, we got it right.
We did. All right, well, time's up, but I'm going to keep going. Actually, before I do that, I need to write your other set of this, and then I'll do 2 more examples. And then I'm going to quit. Not permanently, just, for today. No. Probably eventually, but not today. What I want you to do for this set is page 145. Numbers 2 through 26 evens. Great. Now let's pick up this example. Let's do x squared minus x minus 11 all over x minus 2 less than or equal to 3. What should we do first?
Multiply by the greatest common denominator.
Since this person is talking, I'll subtract 1. Yeah, so would it be easier to subtract 1 from both sides? This is not making a good connection or something.
Yeah.
Must have yanked on it. That's annoying. Okay, but we're good to go now. Welcome back. Stream came back. Great. Put a negative. Let's check it. Negative 2 in there. Plug a negative 2 in there, and we get negative 7 times negative whatever. Is that less than 0? Yes. Plug a 0 in there. Negative times a positive. Is that less than 0?
What?
Negative times a positive. That less than 0.
That's less than 0.
Yeah, because it's negative. Oh, we'd have to check the top and the bottom, because we've got 3. Yeah. So we'd also have to check this. Yeah. Duh. Obviously. Yes, this is true. So roll back the tape. Yeah. So negative in here is negative. Negative 2 in here is negative. Negative 2 in here is negative. So we've got negative, and a negative. We've got 3 negatives.
It's still not, it's like paused.
It's paused.
It's not.
Oh. Well. It's unpaused. All right, we should be back for real this time. Let's leave the computer sitting like that, and then maybe we'll not have issues. Great. So we plug a negative 2 in here. You have to check the sign on all 3, including the bottom one. We can use the fact that's now brain is braining, right? We can use the factored one, but you got to check the sign on all 3 chunks, right? Okay. So negative. Double check if that works with like the answer I'm saying. Did we say this worked or didn't work a minute ago?
That did work, I think.
Yeah.
I have it marked down as it did work.
Yeah, it worked.
And so did 0.
0. Does 0 work?
0 minus 5, negative 5.
So we put. Let's see. Let's actually do this out. While I'm trying to do things too fast because I'm trying to get done. Because class is over. So we put a negative 2 in there. Let's just do it here. Negative 2 squared is 2. Plus 2 minus 11 is negative up there. Right? Mm-hmm. A negative 2 in here. Negative 2 minus 2 is negative down here. Negative over a negative. Minus 3. Yeah, it's always going to be minus, so we're always getting smaller. This is what happens when we try to do too many things in our brain, right? Yeah, it definitely works. This definitely works. Put a 0 in there.
0 minus 0 minus
So negative 11 over negative 2
is positive.
Positive 5 is positive 5 something less than or equal to 3.
Yeah. No, it's
No.
No, so it doesn't.
Great. We plug a 3 in there. 3 squared is 9. Minus 3 minus 11.
That's negative something.
Negative 14, negative 5, right? Plug a 3 in here, we get 1. Is negative 5 less than or equal to 3? Yes. Does work.
6.
Plug a 6 in there, sounds great. 36 minus 6 minus 11.
So it's 30 minus 11.
29. We're plugging a 6 in.
29.
What did you say?
19, sorry.
36, right? So 30 minus 11, yeah, is 19. Yes.
19 over.
6 in here, we've got over 4. So is that less than 3? No, it's not.
Yeah, 4 point something.
Okay, so how do we write that? in interval notation?
We have to use a couple unions.
We do. So it's going to be from negative infinity to -1, including the -1, unioned with 2, including the 2, to 5, including the 5. And then that's it. And I think that's enough. Goodbye. Go away. Find somebody that loves you.
The guy says, therefore you, hold on. X plus 1 times x minus 5 over x plus 2 equals 0. Okay. Therefore, using critical points is above the answer. Is the above answer.
It's the but. Well, the answer is the right is the interval. But yeah. Okay, that's all we're doing today. Goodbye, kids.